Hi, this is Hatham from HorsepowerCalculators.net, and today we're going to be talking about tuning the Mercedes SL65 AMG. Let's talk a little bit about the specifications for the stock engine. The 2010 Mercedes SL65 AMG is a 6-liter, 604 horsepower V12 engine. It has a 5,950 RPM redline. It produces 604 horsepower at 4,800 RPMs. 738 foot-pounds of torque at 2,000 RPMs. It's a 36-valve single overhead cam engine, which has a single large intake valve and dual exhaust valves, which is typical of most Mercedes engines. The single intake valve limits flow at very high RPMs, but most Mercedes engines are designed to be torquey, low RPM engines, and the single offset location intake valve helps the air tumble in the combustion chamber, which boosts low RPM efficiency and low RPM torque. It has a bore of 82.5 millimeters and a stroke of 92.96 millimeters, a compression ratio of 9:1, and it's a twin-turbo engine from the factory running a peak of 12 pounds of boost. The older model, the 2009 and older, used to run 17 pounds of boost because it used smaller turbochargers that had more restrictive turbines. It also had a more restrictive exhaust system, so it required more boost pressure to make the same power level. The new 2010 makes 600 horsepower at 12 pounds of boost in stock trim. Now, what we're going to be doing today is, in today's tuner report, we're using the turbo calculator to design a complete one-off turbo system for the SL65 AMG. This engine has been successfully tuned by Brabus, north of 800 horsepower, and more recently tuned up to 1,015 horsepower by the AMG spin-off MKB. The M in MKB stands for the M in AMG. It's the same guy, the three people that founded AMG. One of them went off to start MKB, so it's a really big tuning house in Germany, and they really specialize in Mercedes, and they know what they're doing. In their P1000 package, the Black Series of the SL65, they produce 1,015 horsepower, and that's what we're going to try to do today. Our goal is similar to theirs. We're going to extract more than 1,000 horsepower safely from this motor. We're going to use a new camshaft. We're going to swap out all the engine auxiliaries, including a custom intake and exhaust manifold. We're going to do a custom parallel twin turbo arrangement, and we're going to do a custom turbo back exhaust system. With the exception of the new camshaft, the remainder of the long block is going to be left stock. Our calculator is also going to cover related support systems such as fuel systems and ignition upgrades. And in the report I have some links here for more details on the MKB press release, or if you want to look at more pictures of the SL65 AMG Black Edition or the Black Series P1000, you can go ahead and do that from our webpage. So let's get started with the calculations. I have the stock numbers here, and I've already loaded up the power calculator. I'm going to skip the performance calculator and the power calculator and go straight to my power calculations. So this is a 6-liter. My engine is a 6,000 cc engine with 12 cylinders and a 5950 RPM redline. It has a single intake valve and dual exhaust valves. The cylinder bore, let's look at the numbers here. Cylinder bore is 82.55 millimeters, and the stroke is almost 93 inches, not 93 millimeter, 92.95 millimeter. I don't know the rod length, but we don't need it for this calculation. The compression ratio is 9:1. Peak horsepower is 604 horsepower at 4,800 RPMs at 12 pounds of boost. And we're shooting to make 1,015 crank horsepower. Single throttle body. It doesn't matter for this. I'm not sure if it has a single or dual throttle body, this engine, but I believe it's a single throttle body with a true dual exhaust setup, and we're planning on a turbocharged buildup. We're actually planning on a twin turbo buildup, but I'm going to say turbocharged over here, and I'm going to click the calculate button. Then I'm going to go to my advanced tab. We're not changing the bore, we're not changing the stroke, we're not changing the compression ratio. We're going to go down here to the chargers arrangement. We're going to go for a twin charger, which is a twin turbo or a twin supercharger setup. And that's all I need to change here. Still going to run on gasoline, and it's still going to be a return style fuel system. Click next, and these are my results. So the results are that we're going to make 1015 horsepower at 21 pounds of boost pressure. And to do that, if I scroll down here, click Next, I get an illustration of the system for my piping dimensions. Click Next again. This is the illustration of the specifications for my head, the camshaft, the lift, and the valve diameter, and the camshaft duration, all that stuff. Just click Next, and these are my turbochargers. These are the turbochargers that I can use in a twin parallel arrangement to get 1015 horsepower out of this SL65 AMG. Let's take a look down the list here. The GT37 52 trim, or something like the Borg-Warner S256, maybe a Garrett GT40, but those are a little larger. Two of those are good for 1200 horsepower, so that's a little larger than we need. So any two turbos on this list, any pair of a turbocharger on this list is capable of doing it, and we can choose the highest efficiency turbocharger, or we can go and look up the compressor map for that turbo and plot our engine demand on it to make sure we fall exactly on the right area in the map where we get peak efficiency, and that would be the best match turbo of these on the list for this application. So that's basically our calculation, and that's how you use the power calculator to do a twin turbocharged setup on a V12 engine for your SL65 AMG. One of the things, if you go back to the results here, you'll notice that for 21 pounds of boost, the calculator recommends 4 steps Colder spark plugs, and it also recommends an 8.1 to 1 compression ratio. Since we're not going to take apart the long block, and since MKB didn't do that in their build-up, then we're going to assume that you're going to have to deal with the added combustion pressure either with additional cooling, or maybe with a little more camshaft overlap, or with a conservative tune both on your timing and fuel, because you have a little bit too much static compression ratio for this boost level. So it's going to have to be a conservative tune to make up for that added compression. Also, if we scroll down here in the results, you can see all our fuel calculations, our wastegate dimensions for a single wastegate, or a dual 48, or let's say dual 45mm wastegate, and our fuel calculations. Let's look at the injectors. We need 12 507, let's say 500 cc per minute injectors to pull this off. So all your calculations here, very quick, very easy. You can just go find these parts, order them, and build this tomorrow. Right? Thanks for joining us on our first of 52. I'm going to do one of these a week. Our first edition of the horsepowercalculators.net tuner report. And if you want your car, or if you're interested in a certain build-up, you can just contact us. We might include your car as a build-up in one of our reports. You can just contact us either on Twitter using the @PowerCalculator, or use the BoostNation hashtag. So you just use #BoostNation, or send a message @PowerCalculator on Twitter, or use the website horsepowercalculators.net and just use the contact form on there and email us your information, your car information, the engine setup, and all that. Thanks for listening, and this is Haitham from horsepowercalculators.net.